discovery of natural antibiotic penicillin was in 1928 by Alexander Fleming. Large-scale production of penicillin by Fleming together with Howard Florey and Erskine giving them the Nobel Prize in Physiology and Medicine in 1945. In 1928, Dr. Alexander Fleming has discovered mold growing on a petri dish of Staphylococcus bacteria. The mold seemed to be preventing the bacteria from growing. He soon discovered that the mold produced a self-defense chemical to kill the bacteria. The substance was named as penicillin.
Antibiotics are produced industrially by the process of fermentation, where the source of microorganism is grown in a large container. Oxygen concentration, temperature, pH and nutrient level must be optimal. The population size must be controlled very carefully to ensure maximum yield is obtained before the cell die. Once the process is complete, the antibiotic must be extracted and purified to crystalline product. This is simpler to achieve if the antibiotic is soluble in organic solvent. Otherwise, it must be first removed by ion exchange, absorptions, or chemical precipitation.
Alright, we move on to the first type of antibiotic, which is penicillin. Penicillin is one of the most commonly used antibiotic globally, as it has been used over 75 years old. It is a beta-lactam antibiotic class of drugs, and it is effective against many different infections such as most anaerobes, gram-positive rods, and more. Besides, it is still widely used today, although many types of bacteria have developed resistance toward penicillin, and it does not work on viral infections such as flu. So originally, penicillin is obtained from penicillin molds, mainly P. cosogem and P. rubens, and most of these penicillins is in clinical use are synthesized by P. cosogem by using deep time fermentation and then purified. So here are some examples of penicillins, and there are side effects for particular penicillin. Next antibiotic is macrolide. Macrolide are naturally occurring compounds comprised of a lactone ring with deoxy sugars attached. It is a bacteriostatic, which it inhibits the bacterial growth rather than killing the bacteria completely. So macrolide act as inhibitor by binding to a specific subunit of ribosomes in susceptible bacteria, thus inhibits the formation of bacterial protein. So the first macrolide discovered was erythromycin, which is in 1952, that were used for those who were penicillin resistant. So here are some examples of macrolides and the infections treated by the macrolides.
Cephalosporins are beta-lactam antimicrobial that is used to manage wide range of infection from gram-positive and gram-negative bacteria. So, cephalosporin is useful against skin infections, resistant bacteria, meningitis and other infection. Cephalosporins is derived from the fungus Cephalosporium species, which are a large group of bactericidal antimicrobial that is work via beta-lactam ring. So how does cephalosporin work? The beta-lactam ring bind to the penicillin binding protein and inhibit the normal activity. This unable to synthesize a cell wall, which causing the bacteria to die. Fluoroquinolone. Fluoroquinolone is used as therapy of respiratory and urinary tract infection. It active against aerobic gram-positive and gram-negative organism. It acts by inhibition of type 2 DNA topoisomerase, which is required for synthesis of bacterial mRNA. It demonstrates little inhibition of human, host enzyme and have excellent safety record. It is used as treatment for several bacterial infections. Some of them are bacterial bronchitis, urinary tract infection, typhoid fever, and many more.
The next type of antibiotic is beta-lactam with increased activity. Beta-lactam with increased activity is an antibiotic that contain beta-lactam ring in their chemical structure. Beta-lactam antibiotics interact with the cellular formation in bacteria as a result of covalent binding in penicillin binding protein. Enzymes that are involved in bacterioglycan translating in both gram-positive and also gram-negative bacteria. Urinary anti-infective are drugs that are used to treat the infection in urinary tract. Urinary anti-infective will not work properly unless the urine is acidic with a pH of 5.5 or lower. Examples of urinary anti-infectives are metinamine, nalidixic acid, and also nitrofurantoin.
Lincosamide are a class of antibiotics that are commonly used to treat infection caused by anaerobic bacteria. They work by inhibiting bacterial protein synthesis. It is also typically well tolerated, but they can cause side effects such as abdominal pain, and it is important to use lincosamide only when they are necessary and to finish the entire course of treatment. How does antibiotic works? They work by targeting specific parts of bacterial cell or disrupting bacterial process. One important thing to note about antibiotics is that they only work against bacterial infections, not viral infections. This is because viruses are very different from bacteria in terms of their structure and life cycle, so antibiotics cannot target them in the same way. In fact, overuse and misuse of antibiotics can lead to antibiotic resistance, which occur when bacteria evolves to become resistant to the effect of antibiotics.